Article 210.19a3 of the National Electrical Code, or NEC, addresses tapping into circuits. It allows for a 20 amp tap to be taken off of a 50 amp circuit, but only under specific conditions. Firstly, the circuit supplying the tap must be rated at least twice the ampacity of the tap. Secondly, the tap conductor must be rated for the ampacity of the tap. Thirdly, the tap cannot exceed 10 feet in length. Now let's consider ampacity concerns. The total load in the 50 amp circuit must not exceed 80% of its rated ampacity. If the range oven is running at 50 amps, there is only 10 amps available for the microwave hood. If the microwave hood draws more than 10 amps, it could overload the circuit and trip the breaker. Think about simultaneous use. If the range oven and the microwave hood are both used at high power simultaneously, it is likely that the circuit will be overloaded. This could result in a fire hazard or damage to the appliances. There are safety concerns to consider. Tapping off a circuit is generally not recommended as it can weaken the integrity of the circuit and increase the risk of electrical problems. In some cases, the tap would be running through a wall or ceiling, which could make it difficult to access or troubleshoot in the event of an issue. Further, condos often have specific electrical codes and regulations that may prohibit tapping off circuits. It is always best to consult with a qualified electrician to determine the best course of action in a situation. While it is technically permissible to tap off a 20 amp circuit from a 50 amp circuit, it is not generally recommended for the reasons outlined above. A safer and more reliable solution would be to run a dedicated 20 amp circuit for the microwave hood. It is essential to calculate the load correctly. For a 50 amp circuit, the maximum continuous load should not exceed 40 amps, which is 80% of 50 amps. This is based on the standard rule that branch circuits should not be loaded to more than 80% of their rating when the load is continuous, as defined by the NEC. To figure out the total load, you need to add up all the appliances and devices that will be powered by the circuit at the same time. In the case of a range oven and a microwave hood, you must determine the amperage draw of each appliance. This information is usually found on the appliance's nameplate. For example, if the range oven draws 40 amps at its maximum power and the microwave hood draws 10 amps, the total load would be 50 amps. This already exceeds the 80% limit for a 50 amp circuit. In situations where the total load exceeds the 80% limit, the circuit is likely to trip the breaker, especially if the appliances are used simultaneously. Overloading a circuit can also create a fire hazard due to overheating of the wires and components. When determining the load, you must consider the potential for simultaneous use. It is not enough to simply add up the maximum amperage of each appliance. You must also consider how often they will be used at the same time. For example, if the range oven and microwave hood are rarely used simultaneously, it may be acceptable to exceed the 80% limit slightly. However, if they are frequently used together, the circuit is likely to trip. The length of the tap conductors is another critical factor. According to the NEC, tap conductors must not exceed 10 feet in length. This is to prevent voltage drop and ensure that the tap conductors can safely carry the intended load. When installing tap conductors, you must use the correct wire size. The wire size must be large enough to carry the amperage of the tap without overheating. You must consult the NEC tables to determine the appropriate wire size for the given amperage and length of the tap conductors. Overcurrent protection is another crucial aspect of tap conductors. The tap conductors must be protected by an overcurrent device, such as a circuit breaker or fuse, that is sized appropriately for the amperage of the tap. The overcurrent device must be located at the point where the tap conductors connect to the main circuit. This is to protect the tap conductors from overloads and short circuits. When tapping into an existing circuit, you must ensure that the existing circuit is properly grounded. Grounding is essential for safety as it provides a path for fault current to flow back to the source, tripping the breaker and preventing electrical shock. You can verify that the circuit is properly grounded by using a multimeter to measure the voltage between the neutral and ground wires. The voltage should be close to 0 volts. Local codes and regulations often have specific requirements for electrical work. including tapping into circuits. These codes and regulations may be more restrictive than the NEC. You must consult with your local building department to determine the specific requirements in your area. When tapping into a circuit, it is important to use the correct materials and methods. This includes using approved connectors, wire, and conduit. All connections must be made tightly and securely to prevent loose connections and potential fire hazards. It is essential to consider the long-term effects of tapping into a circuit. Tapping into a circuit can weaken the integrity of the circuit and increase the risk of electrical problems over time. This is especially true if the tap is not installed properly or if the circuit is overloaded. If there is concern about the long-term effects of tapping into a circuit, it may be best to run a dedicated circuit instead. It is always best to consult with a qualified electrician before tapping into a circuit. A qualified electrician can assess the situation, determine the appropriate course of action, and ensure that the work is done safely and in accordance with all applicable codes and regulations. There are alternatives to tapping into a circuit, such as running a new circuit from the electrical panel. This is often the safest and most reliable option, especially if there is any doubt about the capacity of the existing circuit. When running a new circuit, you must ensure that the electrical panel has enough capacity to handle the additional load. If the panel is already full, you may need to upgrade the panel to a larger size. If you are not comfortable working with electricity, it is best to leave the work to a qualified electrician. Electricity can be dangerous, and it is important to take all necessary precautions to prevent electrical shock or fire. When working with electricity, you should always turn off the power to the circuit at the breaker before starting work. You should also use insulated tools and wear appropriate safety gear, such as rubber gloves and safety glasses. After completing the work, you should test the circuit to make sure that it is working properly. You can use a multimeter to measure the voltage and current in the circuit. You should also check for any loose connections or other potential problems. Remember, safety should always be your top priority when working with electricity. If you are not sure about something, it is always best to consult with a qualified electrician. The NEC provides specific guidelines for the installation of electrical equipment in residential, commercial, and industrial buildings. These guidelines are designed to ensure the safety of people and property. It is important to be familiar with the NEC requirements for the type of electrical work that you are doing. The NEC is updated every 3 years, so it is important to stay current with the latest edition. The NEC is available for purchase from the National Fire Protection Association or NFPA. In addition to the NEC, there may be other applicable codes and regulations that you need to comply with. These codes and regulations may vary depending on your location. You should consult with your local building department to determine the specific requirements in your area. Proper planning is essential for any electrical project. Before starting work, you should create a detailed plan that outlines the scope of the project, the materials that you will need, and the steps that you will take to complete the work. Your plan should also include a safety plan that identifies potential hazards and outlines the steps that you will take to mitigate those hazards. It is important to have a clear understanding of the electrical system before starting work. This includes knowing the location of the electrical panel, the size of the circuits, and the type of wiring that is used. If you are not familiar with the electrical system, you should consult with a qualified electrician. It is important to use the correct tools for the job. Using the wrong tools can damage the electrical system or cause injury. You should use insulated tools when working with electricity to prevent electrical shock. You should also use a multimeter to test circuits and verify that they are energized before starting work. Proper grounding is essential for safety. Grounding provides a path for fault current to flow back to the source, tripping the breaker and preventing electrical shock. You should ensure that all electrical equipment is properly grounded before using it. You can test the grounding system by using a multimeter to measure the voltage between the neutral and ground wires. The voltage should be close to 0 volts. Overcurrent protection is another important safety feature. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the electrical system from overloads and short circuits. You should ensure that all circuits are protected by an appropriate overcurrent device. You should also test the overcurrent devices periodically to make sure that they are working properly. Wiring methods are also crucial for electrical safety. There are many different wiring methods available, and each method has its own advantages and disadvantages. You should choose the wiring method that is appropriate for the application. You should also follow the NEC requirements for the installation of wiring. Electrical boxes are used to protect electrical connections and to provide a safe and convenient place to make splices. You should use the correct type of electrical box for the application. You should also follow the NEC requirements for the installation of electrical boxes. Conductors are used to carry electricity from one point to another. You should use the correct type of conductor for the application. You should also follow the NEC requirements for the installation of conductors. Connectors are used to connect conductors together. You should use the correct type of connector for the application. You should also follow the NEC requirements for the installation of connectors. Terminations are used to connect conductors to electrical equipment. You should use the correct type of termination for the application. You should also follow the NEC requirements for the installation of terminations. Labeling is important for safety and convenience. You should label all electrical equipment and circuits to identify their purpose. You should also label all electrical boxes to identify the circuits that they contain. Inspection is an important part of the electrical installation process. You should have your electrical work inspected by a qualified electrical inspector to ensure that it is done safely and in accordance with all applicable codes and regulations. Maintenance is essential for keeping the electrical system in good working order. You should inspect the electrical system periodically to check for any signs of damage or wear. You should also have the electrical system serviced by a qualified electrician on a regular basis. Troubleshooting is the process of identifying and correcting problems in the electrical system. If you are experiencing problems with the electrical system, you should consult with a qualified electrician. Electrical safety is everyone's responsibility. You should take all necessary precautions to prevent electrical shock and fire. You should also educate others about electrical safety. You may be wondering about specific code references for kitchen circuits. NEC section 210.11 code requires at least two 20 amp small appliance branch circuits to serve receptacle outlets in the kitchen, pantry, breakfast room, dining room, or similar area. These circuits are intended for countertop receptacles. NEC section 210.52b provides requirements for the location of receptacle outlets in kitchens. Countertop receptacles must be installed so that no point along the countertop is more than 24 inches from a receptacle outlet. This ensures that appliances can be easily plugged in without the use of extension cords. For island and peninsula countertops, NEC section 210.52c requires at least one receptacle outlet to be installed. Islands and peninsulas that are 12 inches or wider must have at least one receptacle. Peninsular countertops require a receptacle if they are 24 inches or wider. NEC section 210.86 requires ground fault circuit interrupter, or GFCI, protection for all 125 volt, 15 and 20 amp receptacles installed in kitchens that serve countertop surfaces. This protection is important because kitchens are wet locations, and GFCI protection can help prevent electrical shock. NEC section 210.12 requires arc fault circuit interrupter, or FSI, protection for all branch circuits that supply 120 volt, single phase, 15 and 20 amp outlets installed in kitchens. This protection is designed to prevent electrical fires caused by arcing faults in wiring. NEC section 210.19 AOM provides requirements for the sizing of conductors for branch circuits. Conductors must be sized to carry the calculated load of the circuit. For small appliance branch circuits, the conductors must be at least 12 American wire gauge or AUG copper. NEC section 210.20b provides requirements for the overcurrent protection of branch circuits. The overcurrent protection device, such as a circuit breaker or fuse, must be sized to protect the conductors from overloads and short circuits. For small appliance branch circuits, the overcurrent protection device must be rated at 20 amps. NEC Section 210.21 provides requirements for the rating of receptacles. Receptacles must be rated for the voltage and current of the circuit. For small appliance branch circuits, the receptacles must be rated at 20 amps. NEC Section 210.23 provides requirements for the permissible load on a branch circuit. The total load on a branch circuit must not exceed the rating of the circuit. For small appliance branch circuits, the total load must not exceed 20 amps. Finally, NEC Section 210.24 provides a summary of the requirements for branch circuits. This section includes information on the size of conductors, the rating of overcurrent protection devices, the rating of receptacles, and the permissible load on a branch circuit.